Okay, good afternoon, everyone. Good afternoon again. How are you? Okay, hopefully you are doing okay today. So, I hope the class that is from group one, okay, everyone will be here. Don't forget to mark your attendance in Putra Blast, yeah, for the group one lab class, okay. So we have finished the lab for 2107 because I have to cover the lipid. So it is 4 hours. We will do 2 hours today and then another 2 hours tomorrow. Okay, for those who cannot come tomorrow, you can watch the video. For tomorrow is going to be the group two lab class. All right. So part of the important macro component that is we have to learn for food chemistry is lipid. Lipid, we're talking about fats because fats, as we know, lipid is a lot of food has the fat component, and fat component also affect many shelf life. We're talking about how fats are very prone to oxidation because of the later we will see because of the double bond. So you see that more saturated fat are more stable in terms of the reaction to oxygen as opposed to the unsaturated fat. Okay, what it means by unsaturated fat, what it means by saturated fat, we will see. We also see normally when we say lipid, okay, we have two types of terms that we use, which is oil and also the solid. Okay, when we say solid, examples are like butter. You see the margarine, butter. Those are solid at room temperature. We're talking about room temperature. Okay, when we say oil, those are the one that we use mostly for cooking, for frying. Those are lipid in liquid form. Okay, so two types of form, and there are so many different types of lipid that you will learn as we go along. Okay. Okay, so what are lipids? When we say lipids, the definition, it is a natural substance. So you see that all or mostly living organisms, either it is for food or non-food, naturally they will consist of lipids in the body or in the, when we say food, naturally occurring food, we will have lipid storage, for example. So when we say lipid, it is non-soluble, non-soluble in water because of the nature of the lipid. When we say it is, when it is not soluble in water, it will be soluble in non-polar organic solvent. What it means by non-polar organic solvent? Non-polar organic solvent ni macam, for example, we have hexane. Hexane is normally being used as a solvent. It is non-polar. Okay, when we see if you can Google or if you are familiar with organic chemistry, okay, when we do extractions for natural component, you have to know what kind of chemical that you're going to extract out. Okay, then we have to choose what kind of solvent we are going to use. So if we want to extract out the lipid component of, for example, non-polar component, which is more of a lipid component from a plant or from a food, we have to use a non-polar solvent. Okay, so if you Google, you can see a lot of solvent that is being used, but the most effective one will be the non-polar. So you will see that it is being organized through the polarity. Like for example, methanol. Methanol is miscible with water. So if you mix methanol and water, they can be mixed, right? So you can see that it is actually quite polar. So you have ethanol. And then we use, do you remember the solvent that we use to extract lipid during lab when we did the proximate analysis. That is another solvent that we use. Last time we use PET ether, right? Petroleum ether. Petroleum ether is also another non-polar organic solvent. So that's why we use that for extraction of lipid during proximate analysis. Okay. However, there are a few exceptions for the definition of this insoluble in water, because lipid consists of many fatty acids. Okay, when we say fatty acid, it has chain of fatty acids, short chain, medium chain, and also long chain. Okay, when we say short chain fatty acid, it is quite small in the C carbon number. Okay, so some of the short chain fatty acid, they are quite water soluble because of the size of the carbon short chain. Okay, and then we have trans fatty acid, trans and cis fatty acid. They are different in terms of how those if you go back to your chemistry class, okay, then the location of this functional group is located in the structure will define whether it is cis fatty acid or trans fatty acid. Trans fatty acid. So trans fatty acid are more water soluble. Okay. And then synthetic fat substitute. Synthetic fat substitute ni banyak a lot of companies use it for because fat, natural fat is actually quite expensive. If you see fat from cocoa butter kan, cocoa butter, you see that cocoa butter is being used a lot in cosmetics now, right? Because of that reason, even for cocoa butter, if you actually read the ingredient when you take the chocolate, okay, if you go for a very expensive chocolate, you can see what is the percentage of cocoa butter is being used. Because cocoa butter is one of the most expensive butter. Okay, if you go and buy the like more cheaper chocolates, and you can see that they use a lot of fat substitute. That means either they use a very little percentage of cocoa butter, or they totally change the cocoa butter the fat percentage using fat substitute. As long as it can give the same structure, but of course you can for those who value or know, especially for trained panelists, they will know the difference between whether the chocolate use cocoa butter or the fat substitute. All right. And then FDA uses definition based on total lipid expressed as triacylglyceride or triglyceride, we call it. Okay, so the total PAG, triacylglyceride, and express it as calorific value, meaning the calorie. Okay, avoiding inclusion of non-calorific fat substitute. Okay, so if you see when we are talking about lipids, we normally scientifically we normally call it triglycerides or triacylglycerides. Okay, TG or TAG. Okay. All right, and then this is the classification of lipid. So we have derived lipid, simple lipid, and also complex or conjugated lipids. So derived lipids, that means the unit which is from larger lipids are being built. Okay, for example, fatty acid, alcohol. Alcohol can also be part of the derived lipids. Okay. For simple lipids, it is hydrolyzed. Hydrolyzed meaning the breakdown. Okay, breakdown to two components, usually alcohol and also acid. The examples are acylglycerol, ether acylglycerol, sterols. Selalu kita dengar sterols ni dalam formulation like plant sterols kan. So these are actually simple lipid. Wax also can be found in plants and wax esters. Okay, and then we also have another one which is conjugated lipids. So hydrolyzed to 3 or more components. So break down to 3 or more components. For example, phospholipid. Phospholipid ni the other phosphor group that is combined together with with lipid. Okay, they also have glyceroglycolipids, or we call it glycolipids. Glycolipids ni, glyco means component of sugar. Okay, so it is combined with lipid, and we also have sphingolipids. This is like a combination of not just lipid with other functional groups. So when they combine, it becomes a more complex structure. So we call it complex or conjugated lipids. Okay, so this is what I was mentioning just now. When we talk about types of food lipids, okay, so we have the fats and also the oil. Okay, when we say fat, normally we are referring to the physical fat, which is the solid fat at room temperature. Okay, we don't call oil fat normally. Okay, although both also means lipids, right? But normally we call the like lard, okay, lard, butter, tallow, these are all fats. In physically, it is solid at room temperature. Okay, for this type of fat, mostly they are from animal origin. Okay, like butter normally from milk. Okay, butter we made it from milk. Lard is from swine or from pork, and tallow is mostly animal fat lah, animal fat from beef or from goats and whatnot. Okay, all right, and then this type of fat, why is it solid at room temperature? Because they contain higher component of saturated fatty acid. Okay, saturated fatty acid meaning that all of the bond in the fats, they are mostly saturated, means there's no double bond. It's more single bond. So when they are saturated, they are not prone to oxidation. So they are more stable. Okay, they are more stable. So that's why you see a lot of butter, they are quite stable at room temperature. Lard, so these type of fats are being mostly used in food, in food for baking, for example. Okay, and then there is another type which is oil. So when we say oil, we normally referring to fat, to lipids that is liquid at room temperature. So like palm oil, olive oil, then those are what do you call it, liquid at room temperature. Okay, later in part 2 we will see processing. During processing, in processing, we or the manufacturer normally we can actually change the oil to become solid at room temperature. So that's why when you buy spread, kan kalau kita pergi supermarket, okay, you go to supermarket and then you see you want to buy spread apa, butter lah, we call it butter or margarine that we want to put on the bread, right? But there are so many different types kan, ada yang sunflower, ada yang olive kan, but you think that olive actually is oil, right? How do they make olive become solid? So that's a process of making it. Nanti part tu kita tengok. We will see how some food manufacturers change the oil component of lipid to become the solid, so that it's easier to spread kan. Sekarang ni kita tengok banyak. If you buy pure butter, okay, if you like to cook, for example, right? So when we want to use the butter, the pure butter, for spread on the bread, or we want to use it for baking, normally you have to put at room temperature for it to become softer, right? So for baking, normally we will use soft butter. We don't use the hard butter, right? But now food manufacturer, they you can see in the supermarket the fat the section where you used to buy all these cheese and whatnot. You go over there and you can see all these new products that are coming. You have the spreadable butter. So how do they make butter more spreadable? Okay, so there will be processing involved, or changing of the chemical component of the fat or the lipid, so that it is more likable to consumers. Normally kalau kita nak sapu dekat roti, we want it to be able to spread it directly when we take out from the fridge kan. After a while, if you put the spreadable butter on at room temperature, nanti when you open it, it will become more oily. Then you don't like consumer doesn't like that kind of texture lah. So normally, so this is what manufacturer has been doing. So they try to tackle the issues of this fats versus oil room temperature, and at the same time they will use this because for consumers normally this kind of oil they are more healthier in terms of they are more less saturated fat like olive oil, safflower oil, canola oil. So you can see all these ingredients in the spreadable butter that you use for your breakfast, for example. Okay, so this oil are mostly plant origin. Macam we have very famous, Malaysia is one of the world producer of palm oil, Malaysia and Indonesia. Okay, which is being used a lot in food products. Okay, palm oil, and then we have coconut oil, olive oil, safflower oil ni bukan kita punya lah. These are all from Mediterranean, US, like soybean oil. Okay, so these they are mostly plant origin. Mostly they are unsaturated. Okay, so this oil they have higher content of unsaturated fatty acids. So because of the unsaturated fatty acid, so at room temperature they become oil. Okay, in nature. Okay, for fats and oil for the world supply. Okay, for the world supply, vegetable oil is about 68%. So you see that a lot of in the market, you see that when people use a lot of vegetable oil, including palm oil. And the animal fat are being used in certain types of food products is about 28%, and marine oil ni dari mana? Marine oil ni from the fish oil fish oil are mostly being used as a supplement. Because why? Marine oil ni is not so much being used in food product, because one, it is very expensive, because you have to extract the oil from the fish. Okay, and also marine oil it is highly unsaturated, so they are more prone to oxidation. Mostly they are not stable lah, but normally people use this for supplement. Supplement kan kita banyak if you see in the pharmacy they will have this marine oil as a supplement, macam minyak cod liver oil, banyaklah. They have a lot of this type of oil. So it's about 4% of the world supply. So vegetable oil are extracted on the industrial scale with solvent. This is what I was mentioning just now. So we have to use type of solvent that can extract most of the oil from the source. In terms of vegetable, for example, soya, canola, sunflower. So the oil is mostly in the plant, mostly in the seed sometimes. Seed, dia ada banyak high percentage of oil. So they are being extracted out at an industrial scale with solvent. So this solvent usually is a mix of hexane isomer. Hexane isomer ni not just the hexane, dia ada banyak isomer like sea vapor kan. So depending on some isomers, hexane isomers, they will act differently with different types of fatty acid in different types of vegetable oil. That's why you have to use certain hexane isomers for certain type of oil. Okay. Palm oil is extracted through screw press. Maybe you get a chance to go to palm oil processing during one of your courses, right? If you, I'm not sure which course, that maybe through your degree you get to see this maybe site visit. If you got the chance, please go to this palm oil extraction. Okay. And that solvent is percolated through a bed of crushed seeds and then distilled off as an azeotrope to leave behind the extracted oil. So you can actually see this maybe in videos in YouTube. Some Dhabi, for example, we have KLK, we have Sam Dhabi is a big has a big share for Malaysian plantations for palm oil. Okay. So this defatted residue used to make soy protein powder. Okay. So this defatted residue. All right. And then we have what are the functions of lipid? Okay. So lipid, we know that lipid is the source of energy. Just like the carbohydrate, lipid also can be energy source and reserve. Okay. So for insulation, for example, so if you compare carbohydrate and fat, 1 gram of carbohydrate is 17 kilojoule of energy. As compared to 1 gram of fat, we can supply you 37 kilojoule of energy. So for diet purposes, in terms of the balancing between the intake and also the energy expenditure. Okay, so when the food intake is greater than the energy expenditure, that means you don't use a lot of energy and burn the fat. So this excess energy is stored as fat dalam badan. So that's why during with balanced diet, we also have to expand. We also have to use the energy. That means we have to go exercise to burn the fat or the food intake, the fat from the food intake that we take from our meal. Okay. And then the other one is insulation. We know that fat can be a co-conductor of heat, so fat can help in terms of insulation. Okay, satu lagi, the important thing is structural element of membrane. If you can still remember your science class dulu, you learn about this, maybe you learn about this in biology class. Okay, so in this membrane, normally dia ada phospholipid kan, dekat you have the hydrophobic tail, the head is hydrophobic and then hydrophilic tail. Okay, so this structural element of the membrane, dia ada phospholipid. Like I said, you have phospholipid, you have sphingolipid, and you have cholesterol. Okay, so these are the membranes lah. Okay, so structural element of membranes ada contain all these type of lipids which are very important in the structure. So kalau tak cukup or not enough lipids to be able to build this phospholipid, sphingolipid, and cholesterol, that means the structural element of the membrane will be weak. Okay, and then for functional molecules, fat can be hormones, can also be vitamins. Vitamins, kita ada fat soluble and non-fat soluble. We have the water soluble vitamins. We have the fat soluble vitamins, the A, D, E, K. Okay, and then fat can also be cofactor of the functional molecule. So if you don't have the fat, some molecule may not be function properly. Okay, fat at the same time is a flavor element. So kalau tak ada fat, kita kurang flavor. Okay, so that's why some macam sekarang kan, now people use lesser fat, lesser fry kan. You use air fryer, use different types of maybe you put it in the in the oven, for example. So you can actually feel the difference between if maybe, okay, for example, we use one type of curry puff, contoh curry puff kan. Okay, you take the curry puff and then you fry it in oil versus the one that is used in air fryer. Which one tastes better? Okay, of course, the one that you fry in oil, because oil, other than, of course, it contributes to this energy source, it also contributes to the flavor. So the one that has more oil has more flavor, as opposed to the one that you don't use oil. Kan kalau kita letak dalam air fryer, you use maybe 1 teaspoon or 1 spoon of oil, kan? You just use the heat. Most of the heat is being used to fry the curry puff, right? So that's why you can taste that it is not the same, not the same taste, right? Okay, food uses of lipids. Okay, one is improve flavor and texture. Okay, like I mentioned, okay, fat can contribute to the flavor and texture of food. Semi-solid character has distinctive mouthfeel. Okay, fats can act as carrier and other flavor elements. So as part of giving the flavor itself, fat can also act as a carrier of other flavors. Okay. Alright, fats have their own taste and sometimes odor. Okay, this one, different fats will have different taste and odor. Okay, and then moisture retention. Because I'm not sure if you can still recall your water class with Dr. Alia. Because water, they are not just H2O molecule that act on their own, but water can also have a reaction, right? Reaction or can bind to other molecules. Because in food system, you have all these macro components, they actually work with one another. They either react or they either bind, become a more complex molecule, right? So this fat can be a moisture retention. So kalau ada one type of food that has higher fat, it when you cook them or when you bake them, it can retain more moisture than the one that it has no or less fat. So you know that if you eat some food that tastes more not dry, okay, so you know that they will have fat in it because of moisture retention from the fat. Okay, frying medium, okay, we know this. And then satisfaction ni like the one that I compare when you fry your curry puff in oil and the one that you use with non-oil, kan? So it gives you more satisfaction when you eat the one with fat, right? Because one element in satiation or satiety is fat or lipids lah, okay? So low fat diets are not well tolerated. Okay, this one is or more into satisfaction. Okay, then we go to the classification scheme. So this lipid, like the one that I showed you earlier, okay, it consists of simple lipid, okay, wax, sterol, triacylglycerol, complex lipid, and also derived lipid. Okay, kalau complex lipid ni, here are the phospholipid, can be, because like I said, if you imagine complex means something that is bigger molecule, right? So bigger molecule macam normally it has something that binds to it. So phospholipid ni, it has glycerol phospholipid, it has sphingolipids. So these are the examples lah, like phosphatidylcholine, phosphatidyl ethanolamine, phosphatidyl inositol. These are all examples of phospholipid. Okay, and then we have sphingolipids, ceramides, sphingomyelin. Okay, these are component of phospholipid. And then other than this phosphor group, we also have glyco group. Glyco group, for example, cerebrosides, gangliosides. These are all under category of glycolipids. Okay, so these are the general classification of lipid. Okay, so major lipid component, okay, for main types of lipids, major component of this lipid are fatty acid. Okay, nanti kita tengok apa maksud fatty acid. Okay, and then we have acylglycerols or glyceride. Like I mentioned, whether we call it triacylglycerol or triglycerides. Okay, so acylglycerol and glycerides are the same. Okay, and then we have glycerols or phosphatides. Okay, these are the major lipid components, or more than 99% of fat component consist of this component. But there are also some parts of lipid component which is called minor, which is tocopherol. Tocopherol ni apa? Normally used in tocopherol is antioxidant kan? Antioxidant normally used in to combat this oxidation lah. Okay, sterols, plant sterols, wax, pigment. Pigment can also be lipid component, hydrocarbon, glycoside, and vitamins. Okay. These are all, although they are minor, but they are all under category of lipids, under category of lipids, but they are very minor. Okay. And then we go to fatty acids. Okay, fatty acids. So the way you write fatty acids is COOH, C double bond O, OH. So this is the carboxylic group. Carboxylic group COOH, the one that we write. So COOH, the C, they are the double bond with O, and then with hydroxyl group lah. So this hydroxyl or carboxylic acid group has this hydrophilic head group. So whenever you see a compound with an OH, normally they are more hydrophilic. Okay. And then we have R group. Okay. R group ni is the one that confer the non-polar hydrophobic part of the lipid. Okay. So dia akan ada yang di end tu, dia ada just like protein, right? Protein, if you can still remember what Prof taught you, protein has the CN dengan the carbon N, we call it the C terminal. We also have the N terminal then, because amino acid, right? Amino acid has amino group dengan acid group, right? So that's why it is called amino acid. Okay, because we have the carboxylic acid group, we have the amino group. Okay, and then when they combine together, so we call it N terminal dengan C terminal. Okay. So this one pun sama. So we have an carboxylic acid terminal, but in fact we don't call it terminal, we call it group lah. Okay, carboxylic acid group, and we have the R group. So this carboxylic acid, because of the OH, these are the one that gives you the head. The head tu yang duduk kalau kat membrane, the head tu yang duduk kat luar. Kan? The tail yang, so if the membrane is double layer, right? So you have the head is the hydrophilic part, and then the tail is the hydrophobic part because of the R group. Okay, most commonly linear and even number. Okay, these are fatty acid lah. When we try to write the fatty acid, normally we write it as C16, C18, C20, C22. They are mostly even number because of the synthesis of two carbon unit lah. And they are mostly linear. Okay, linear means with straight lines into it. But however, some has branch and odd number fatty acid also exist. Okay, especially for microbes lah. Okay, for microbes. Let's see what we have here. Okay, nomenclature for IUPAC convention, fatty acid and free fatty acid are named after the parent alkene. So dia punya group alkene group. Okay, so this is alkene group. The CH3. Okay, the CH3, 1, 2, 3. Okay, for example, octadecane and octadecanoic acid. Okay, so this is octadecanoic acid. So if you see the structure, okay, so this is where you have the carboxylic acid N. Okay. Okay. So they use the symbol yang triangle symbol. Okay, this triangle symbol is to tell you, okay, the nomenclature, where is the location of the double bond. Okay, so kalau ada double bond, this fatty acid is unsaturated. Okay, sebab dia ada double bond. Okay, so how do we know where is the location? Is to see the structure and then the symbol. So if it says delta 9 octadecanoic acid, so delta is the triangle. So it starts from the carbon number 1 yang COOH punya N. Okay, so it's here is written that So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the delta 9 means that the location of the double bond is at carbon number 9. Okay, kalau macam ni, 9, 12 octa dienoic acid. So dia ada dekat nombor 9 dengan nombor 12, 13 ni lah. Okay, so if it's delta 9, 12, 15, so it will have at 9, 12, and 15 kat sini. 15 and 16. Okay. So the nomenclature is like that. That is one of the nomenclature that some people use to name the fatty acid. Okay, fatty acid also, fatty acid contain monocarboxylic acid. They are generally from C14 to C22. General saja. This is general, like mostly when you see the number of fatty acid, normally it's written as C14, C16, C18, C20, macam tu C22. But ada juga yang odd number tadi kan. Okay. Generally, even number of carbon, most abundant in food are C18 and C16. Okay. And then, of course, they have double bonds because, like we say, one is from the animal source, one is from the plant source. Okay, yang plant source ni, because they are unsaturated fatty acid, okay, normally they have double bond. So for the unsaturated fatty acid, they will have double bond. Okay, because of this number of carbon, number of double bond, so this will affect their boiling point and also melting point. Okay, so the kalau for example, I'll give you melting point kan, melting point of chocolate, cocoa butter. So that's why some company came up with when you eat a chocolate, it should melt in your mouth, not in your hand kan. Company apa yang pakai macam tu kan, the tagline tu. Okay, when you use a pure cocoa butter, the melting point of cocoa butter is about 36, 37. So human body is about 37 kan. So when you hold the chocolate in your hand, it shouldn't melt until you put it in your mouth. That's why you have the satiation tadi tu. When it comes to satiation or satisfaction of eating the chocolate. Okay, if you learn like food science, normally we have this course. It's called sensory analysis of food. So when we formulate some new formulation of food, or we adjust, we want to make a new product, so we will have the sensory analysis. So we will call general public to taste, to give you the taste, which one would you like, and then they will do some analysis. Okay. For this type of purposes, these big companies, they will have people who we call it trained panelists. Okay, trained panelists ni banyak guna dalam chocolate industry, and also if you're familiar, if you like to use perfume, this is not food lah, but I'm talking about sensory analysis kan. They will use this trained panelists, and this trained panelist has a very highly paid people, because they have been trained to acknowledge, macam for example, in their body or in their mind, they have their own order notes, especially for those that involved in perfume industry lah. Normally kalau dia kan big companies will have this new type of perfume kan, so they will mix all these ingredients, and this new bottle formula, before they release to consumer, they will go through trained panelists lah. So these trained panelists will, when they smell, okay, they will know what is this formulation will have, what type of order they will have. So they know, because this human being that is being trained for doing order for a perfume company, their order notes is wider than instrument punya library, ya. Okay, I actually many years ago we have one professor that came from, I can't remember now. So in his order notes, dalam dia punya mind tu, he can identify more than 1,000 single note order notes, which is crazy. So bila dia bau je, dia tahu apa yang ada dalam that you put in the bottle lah. Okay, so that's how expensive, how much they are being paid because of that particular skill that they have. So this one lah, like one that I mentioned, the melting point too. So when those in chocolate industry, okay, they know that when for example you have expensive chocolate like patsi kan, tahu tak patsi? Okay, if you go to LCC maybe have IOI, I'm not sure. Okay, try to buy one patsi chocolate and then taste it and compare with apa kita ada Cadbury, we have berries lah, berries paling ni lah common. Okay, try to compare that one and see what is the difference. Okay, so because the one that is being used, if you use pure cocoa butter, all this cocoa mass, it should melt in your mouth, not in your hand. Okay, because cocoa butter, dia punya melting point is about 37. Okay, alright. I think you can go to Barrel's punya factory here if you are curious about how they make the chocolate. Okay, they actually display from outside. They have this glass wall. You can actually see the process of making chocolate. Okay. Order decrease as C number increase. So that means bila C number ni from 14 to 22, when the C number increase, the order will decrease. Okay. Let's see 12 and higher are orderless. Okay. Short chain fatty acid have marked SCFA. Okay. Short chain fatty acid have marked order, for example, acetic, propanolic, and butyric acid. Okay. They have a distinctive order, right? I'm not sure if you can see this paper. This is from the Lipid handbook, Chapman and Hall. Okay. Ni systematic name and the trivial name, and this is the apa ni number of carbon number of carbon lah, 1 carbon, 2 carbon. Methanoic acid or methanoic is formic acid, so dia punya carbon 1. Ethanoic acid macam tu ethanoic, acetic is an acetic acid, carbon 2. Propanoic acid, butane is carbon 4. Ingat tak dulu kita pernah hafal ni during our organic chemistry kan? Hexa is 6 lah. Hexa is always 6. Octa is always 8 kan? Deca, nona. So these are the trivial name. Okay, we see that kita tengok start. Kalau in food normally we start from sinilah lauric acid. Lauric acid or it is called dodecanoic acid. It is 12. The melting point is about 44. Okay, 44. Then we have palmitic. Palmitic ni banyak dalam palm oil lah. It's 16O. The melting point is 62. Okay, 62. Then we have stearic acid. We have linoleic acid, linolenic acid. Banyak lah. Okay, you don't have to memorize this. Is this information? And then as you go along, okay, for example, as the C is higher, the melting point is also higher. Okay, so tengok yang mana at room temperature. So if you see here, room temperature, katalah Malaysia is about berapa? 30 kan? 28 to 30. So anything less than 10, okay, dia tak melt lagi lah. Okay, dia tak melt lagi. So that means this one 31, 44. Okay, dia kena higher temperature for it to melt. Okay, like 52. Palmitic is about 62. Okay, 62. and then behind it is about 80. Okay, as we go along, the higher carbon, the higher melting point. Okay, that's the message lah. This one is structure. This is how it is being written. Okay, systematic name, trivial name, and shorthand name. Okay, kalau yang ni dia ada dia punya number of double bond. Okay, this is number of double bond. So for example, we see lauric acid is 12O. That means there is no double bond. And then we see that palmitic is 16O, no double bond. Octadecanoic acid is stearic acid, also no double bond. So we have this one, olic acid. Okay, 18.1. This is 9. This is the location. This is actually the location of the double bond. Okay. Right. Okay. Structural classes of fatty acid: saturated, unsaturated. Kalau dia saturated, meaning there is no double bond. Okay. Kalau unsaturated, it can be mono unsaturated. That means satu. Mono is one. You have one double bond, or you can have poly. Poly, you can have more than one double bond. So we call it omega-3, omega-6, omega-9. Okay. And then we also have branch or cyclic fatty acid, which is minor. Okay. So cis and trans conformation. Okay, this one is the one that we call it the location. The location dekat double bond tu kat mana dia, sama ada it is parallel or it is perpendicular. Okay. So example C9 octadecanoic acid. All natural occurring fatty acids are cis. Okay. So mostly they are cis. Tapi banyak macam kan foods like cheese kan, or the one that is being used because of the reason the manufacturer have to change to the favor of the consumer for stability. Normally dia akan tukar kepada trans. Trans are more stable than cis lah. Okay. So that's why you see a lot of health, doctors, they will recommend not to take food that has higher trans fatty acid punya element lah. Okay. So because all natural occurring fatty acids are cis. Kenapa dia jadi trans? Okay. Because food manufacturer tukar jadi trans so that for the stability of the life of food compound. Okay. Okay, this is what. This is an example lah. Okay. Okay. So this is fatty acids, shorthand N, or ditulis macam omega lah. Okay. This omega. The number of carbon in the chain is followed by colon. Okay. Yang macam 16 colon tu double dot lah. Okay. 0, the number of double bond followed by the number of double bond closest to the methyl end of fatty acid. Okay, because tadi kita tengok ada yang COOH, ada yang methyl end kan dekat sini. Sini kan. So this side is the COOH side, this one is the methyl side. Okay, so kalau macam protein, satu dia ada COH, the other one is amine. But for fatty acid, one is COH, another one is apa? CH3, methyl group. Methyl CH3 is methyl group. Okay. Okay, the number of carbon in the side chain, in the chain is followed by colon, so double dot, the number of double bond. Kalau ada double bond, dia akan tulis 1, 2, 3. So 16,3 is 16 carbon, double dot 3, meaning dia ada 3 double bond. Okay, followed by the number of double bond closest to the methyl end. So starting from the methyl end. Carbons are numbered from the methyl end of the molecule. The letter W ni, macam W macam omega, is often replaced with N. Okay, depending on how they are being written, the nomenclature. Okay. So saturated fatty acid, they are smaller, saturated fatty acid smaller Molecular weight species are water soluble but decrease in solubility as size increase. Macam tadi kita tengok, if you go like higher C, the melting point will be higher. Okay, so sama macam kat sini, so solubility will decrease as the size is higher. So the higher, like C24, will have less solubility as compared to C14. Okay, that one is for the saturated fatty acid without double bond. Okay, yang dia punya belakang double dot zero. Yang zero tu semua saturated fatty acid. Okay, unsaturated fatty acid is the double dot one. Okay, kalau mono lah, mono unsaturated are mostly delta 9. Okay, delta 9 location number 9 from the tadi kita tengok kalau dia tulis delta 9 is carbon number 9 from the carboxylic side. Okay, polyunsaturated fatty acid has more than one double bond. Okay, which are more nutritionally essential. For example, linoleic acid. Okay, that means yang ni yang lebih banyak kita advise to take lah, the PUFA one, polyunsaturated fatty acid. Then we have acetylenic fatty acid, ionic or dionic acid suffix with denoting acetylenic bond generally at delta 9, but these compounds are very rare. Okay, and the other types of fatty acid. Okay. And then we have trans fatty acid from bacteria for all steam deodorization and all hydrogenation. Okay, satu proses untuk buat macam tadi kan, I mentioned how to make oil, how to change oil to become more spreadable. So if you want it to be more spreadable, you have to make it more solid lah, kan? Macam tadi kan, kita tengok kalau kat supermarket, we have spreadable butter. It's not actually butter, it's spread, they call it. But they use olive oil. Macam mana olive oil kita boleh spreadkan dia dekat atas roti? Okay. So this is the one of the reaction, one of the processing method, they call it. Okay, this is called hydrogenation. Because of the double bond, macam mana nak jadikan dia single bond? So you add hydrogen. So it's called hydrogenation. Okay, hydrogenation. So that is what manufacturers are actually doing lah. Okay. Ini salah satu method. Ada method lain lagi. Okay. Kita panggil interesterification. That one part 2 nanti I will go through with you what it means by interesterification. You can mix the type of fatty acid. You don't have to do hydrogenation because bila kita buat hydrogenation nanti ada nutritional consequences. Kan, nanti food company selalu they want to have something that is at the same time serve the purpose of selling, but masa yang sama at the same time they will reduce the nutritional consequences lah, because they have they have the responsibility to take care of also to take care of the consumer's health. Kan, macam tu. So one method is to use hydrogen. When you use hydrogen, you will convert the double bond tadi, dia akan jadi single bond lah. Setelah jadi single bond, dia jadi saturated. Bila saturated, dia akan jadi more solid. More solid. Okay. Lepas tu metal branching. Ada juga macam just now we're talking about how these fatty acids are more linear, right? But there are incidents where this metal dia akan jadi branch. Branch meaning either they go up or they go down. If you see it in 2D, but if you see it in 3D, then it will go at the back or it will go at the front lah. If you see this 3D structure of molecule, right? So metal branching occurs at this two carbon. Okay, carbon yang ada double bond tu. Okay, especially isoprenoid or terpenoid biosynthesis pathway. Pathway ni macam how to produce this type of molecule lah. Okay, so dia akan jadi metal branching. Okay, let me see, you can see this. This is fatty acid structure with some functional groups found in fatty acid functional group. So you have fatty acid with saturated alkyl chain. So dia akan ada semua saturated, and there's no double bond. Okay, methylene interrupted double bond. Okay, this is methylene interrupted double bond. This one is conjugated double bond. Conjugated double bond ni meaning that dia alternate, alternate single dengan double, dia alternate. Okay. So kalau cis dengan trans macam ni. Kalau cis, dia punya R group tu both located at the same we call it in chemistry, macam same location lah. If you see it in 2D, both will be the same upper part or same lower part. But if you see it in 3D, dia dua-dua ada dekat sebelah belakang atau sebelah depan kan. So actually it goes like this. It doesn't go up and down like this, but you see it in 2D. Okay. And then we have trans. Okay, trans bila dia perpendicular. Perpendicular meaning that one is that direction dia perpendicular perpendicular like this. If you see 45 degrees gitu kan. Okay. You see that way lah. Okay. So location if it is a 3D, dia the other way around. Satu sebelah belakang, satu sebelah depan. Macam tu. Okay. So that is trans. So cis is where you have both at the same position. But trans is perpendicular position. Itu dekat dia punya double bond. Okay. So like I said, if you do companies, they manufacturers, these are more stable lah. Trans punya structure or configuration, they are more stable. Okay. This one is acetylene, alene, metal branch macam ni lah. Branch dia tak aliphatic, maksudnya dia tak straight. It has branch up and down. And then we have the hydroxyl. Ni yang kita panggil yang special structure with either triangle ataupun dia penta. Okay. So if you see something like this is cyclopropane, cyclopropene, epoxide. Epoxide ni dia ada triangle with an O. Okay, epoxide. Furan ni dia punya structure is the one that has a penta with an O. Okay, these both epoxide and also furan, these are all considered food safety punya issues lah. We don't want to have this in our food. Okay, this have to be monitored. Kadang-kadang epoxide and furan ni they happen from it normally it doesn't happen in nature. It is being formed after the fat is being processed. Contoh, for example, epoxide ni dia jadi dalam proses refining, refining of oil. Okay, epoxide furan pun sama lah. Dia macam furan ni mostly happen bila ada combustion furan. Normally it's being monitored. Kalau macam in environment, normally it is being monitored at certain level lah furan. Okay. Okay. And then this one is unsaturated fatty acid in fats and oil. Okay, ini adalah systematic. It is the systematic name. Okay. This one is the location of the double bond lah. Okay. 9-decanoic acid, dodecanoic acid, and then dia punya writing tu 16O, 16 dia tak tulis kat sini ya. Okay. This is number of carbon 10, 12, 14. This is the common name. Salicylic acid, oleic acid, lactic acid, okay, linoleic acid, linolenic acid. These are all PUFA lah. Linoleic acid ada 2 double bond, linolenic acid has 3 double bond. So 18-1 is racemic acid, 18-2 is linoleic acid, 18-3 is linolenic acid. Ini yang common punya you have to know. Macam linoleic acid, linolenic acid, oleic acid, palmitic acid, macam the common fat lah. That one you have to know. Alright. So these are all the melting points. The higher the melting points, okay. But the more saturated, the melting points is lower lah, okay. Typical fat source, okay. This one is in butter fat, palmitoleic acid 16O, mostly some fish oil, beef fat. Ni tengok kat mana where you can find the type of fat, okay. Kalau arachidonic acid, dia ada 20 and 4. This one is in lard, okay. And then linolenic acid is 18.3. You can find it mostly in soybean oil, canola oil, rapeseed oil, the 22.1. Okay, itulah. Okay, saturated fat, all the chemical bonds between carbon are single bond. Okay, this one you know, no double bond. There is no space for more hydrogen atom, are fully saturated. They are solid at room temperature. So, for example, butter, coconut, fattening, nut, coconut oil. Coconut oil at room temperature, it can be saturated. Palm oil, polyhydrogenated vegetable oil, poultry skin, wholemeal, these are all saturated fat. Okay. For polyunsaturated fat, they have 2 or more double bonds. Okay, include omega-3, omega-6 fatty acids. Okay, linolenic acid are omega-3 fatty acid. Linoleic acid are omega-6 fatty acid. Okay, so these are the richest source of polyunsaturated fatty acid. Includes, so kalau kalau unsaturated, mostly they are from plant origin, plant origin. Okay, so vegetable oil lah, corn, sunflower, cottonseed oil. Okay. So kalau kita pergi US kan, US or North America, normally the one that the type of oil that they actually sell in the supermarket, this type of oil lah, corn oil, sunflower oil, cottonseed oil, cottonseed jarang lah ni, sunflower, corn, soybean oil, because they want to promote the industry, number 1. Number 2, it is believed that they use this a lot in frying, but actually palm oil is the most stable oil for deep fry, okay. So they are trying to, because we have a lot of issues of palm oil, they are being embargoed, macam dia sekat lah kita punya the production of palm oil, like Europe is trying to do that, US also is trying to do that, because you know, they mention about how countries like Malaysia, Indonesia destroying our forests because we want to plant more palm oil, palm trees to produce palm oil. But itulah argument is still going on. Like few years ago pun ada from France, they are trying to sekat the palm oil. But still, if we MPOC, kita ada Malaysian Palm Oil Council, banyak buat, they do a lot of promotion, they do a lot of info sharing about the goodness of palm oil, because we are the producer, right? So they spend a lot of money actually, and they have a lot of activities that involve students, involve the NGOs, and also the general consumer. So please try your best to get involved in this kind of activities lah. You can go to the website of MPOC. Even I think last year they had this very big event in UKM. Not last year, just last semester. Okay, maybe you did not get the message, because they sent it to food science students. So we compete there, and then UPM student, our BSTM student got number 1 lah in terms of product development that use palm resources, palm oil resources, which is actually very good. Okay, so don't believe directly what the media is telling you about the goodness of other vegetables oil than palm oil, because from what we have learned and from the research has been shown a lot actually, that palm oil is the most stable oil that is used, the best oil is used for frying. Okay. Alright, ni nomenclature lagi lah, nomenclature macam tadi ya. This nomenclature is C18, this is how it is written. The carboxy N and then the metal N. Okay, so tulislah C punya carbon dia ada 4 kan, for chain supposed to attach with C. So ada 1, if you see here like 1, 2, so the other 2 is by H lah. So yang tak ada, that the one that you don't have any C, you have to put the H. Okay. For example, if there is a question asking you how to draw, how to nomenclature this one, so you have to write it this way. Okay. Okay, name according to the number of double bond. Okay, this one is 18O. 18O is 18 carbon, no double bond sebab dia 18 0 kan, ferric acid. Okay. And then 18-1. Okay, dia punya ni lari sikit. Okay, 18-1. So normally 1 ni satu double bond, the location 1, 2, 3, 4, 5, 6, 7, 8, 9. So number 9 lah. Okay, number 9 from the carboxy N. So dia akan 9. Okay, kalau kat sini 1, 2, 3, 4, 5, 6, 7, 8, 9 juga. Okay, because dia 18. And then 18-2, this one is linoleic acid, 18-2, so carbon, this one is a little bit move, but it's from here lah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 9, 12 lah, dia punya location dia, okay. So 18-2 has 2 double bond, 18 carbon, and 9 and 12. The location of double bond. This one bersama. So normally dia 9, 12, 15. Linoleic acid. Okay. And then fatty acid also are named according to the location of the first double bond from the non-carboxylic. And tadi kita tengok dia name daripada sini kan, yang omega tu. Kan, yang dia delta, 9, 12, 2. Ada satu lagi cara where you can actually give the N system or omega tu. Okay, location of those is from the metal N. So kalau kita nak bagi nama macam ni, if you want to put this kind of name, we have to start from the metal N. So metal N, the metal carbon number 1, number 2 and number 3. So dia akan jadi omega 3. So this one will be or you can have it N3 lah, N-3. Okay, this one is using omega system. Macam banyak that we normally see this term in kat mana? Dalam telur kan. Kita kata beli telur omega. So this egg, normally they have omega 3, omega 6. Sometimes we use oil also, we have what type of omega kan. Macam the one that they use ingredient in in milk also they use this one. So what it means by omega is the location of the double bond if you start from the metal N. Jadi kita start dari sini. If you start from here, you will have a different nomenclature. You use the omega system lah. Okay. So this one will be omega 3, 3, 4, 5, omega 6 and omega 9. Itulah. Sama lah ni ya. Okay, omega 9, carbon number 9 from here, from this part, omega 6, carbon number 6 from the metal part, and omega 3, okay, 3, 6, 9. Alright. This is fatty acid synthesis. So animal can synthesize a fatty acid with a double bond in the omega 9 position, but not at the 3 and 6 position. So that means it has to be given. Animals, for example, ni dia boleh synthesize fatty acid. Kalau dia boleh synthesize fatty acid through dia punya biosynthesis pathway, but not on the 3 and omega-6 fatty acid. So this omega-3 and 6 fatty acid must come from the diet. So kena makan lah. Okay. So cold water fish accumulate high level of omega-3 fatty acid from their diet. So that's why source of the cold water fish, when you do the extraction to get from their muscle, you can get a lot of omega-3 fatty acid. Okay. This one is the omega system and essential fatty acid. Okay, linoleic acid is C18-2, is an omega-6 fatty acid. Linolenic is C18-3, and arachidonic acid is 24. These are all omega-3 fatty acid. Okay, so ini adalah arachidonic acid. Okay, so this is 24 and omega-6. So kita start daripada sinilah 1, 2, 3, 4, 5, 6. Okay, and then 24 is this is location where kalau dia start daripada sini lah. Okay, if you use the omega system, you have to write the one that is the first where the double bond is located from the methyl end. Okay, kalau kita nak tulis macam ni, okay, that is from the carboxylic end, the location. Okay, contoh. Okay, tadi we talk about melting points, right? So melting points, there are many factors that contribute to the melting points. One is the chain length. Okay, so the longer the chain length, the higher the melting point. Okay, if you see here, 12, 14, 16, 18, and 20. So you have 44, 58, 63, 72, and 77. So from here, you can dictate. You can dictate which fatty acid are liquid at room temperature and which fatty acid are solid at room temperature. Tengok dia punya melting point tu. And room temperature normally kita pakai yang 28. Depends on where you are. Normally for Malaysia we use 28 lah for our room temperature. If you are in the temperate countries, like you are in the States, you will normally use about 22 degrees C. But now our room temperature is what, about 30, 32 kan? Sekarang panas kan? Okay, the structure of some fatty acid normally found in drinking aids. Okay, this one is just examples lah. Okay, palmitic acid, stearic acid, palmitoleic acid, oleic acid. Okay, so these are the melting points. Okay, 16O, 18O, 16-1, 18-1. So you see that yang mana ada double bond, punya melting point is very low. So dalam room temperature dia adalah liquid lah. Okay, this one also liquid. Alright, palmitic acid and stearic, they are solid at room temperature. Okay, and then the other one is chain length. In most fats with a mixture of fatty acid, the chain length of the majority will determine the hardness. Hardness ni meaning that how easy for it to become liquid lah. Is the term for solid fat. Okay, nak tahu hardness. But for if we want to measure, you have to use instrument, the hardness, the texture analyzer. Texture analyzer can give you the hardness in terms of the reading using the analyzer. Okay, so if it's less than 10 carbons, it is liquid. Okay, if it is more than 20 carbon, it is solid. So between 10 or 20, they solid ke they liquid? Okay, which one? Alright, so you can see here, acetic acid, it is a vinegar, is liquid. Stearic acid with tallow, they solid. Arachidic acid, 20C, butter, so it is solid. So it actually depending on if you have this kind of chain length, okay, you have to see also how berapa dia punya, how many double bond does this fatty acid has. Okay, sini melting points and double bond. Okay, So you have 18O. So you have the same fatty acid, but a number of carbon, but you have different double bond. Then one is 0, one is 1, another one is 2, another one is 3. So the more double bond, although they are the same number of carbon, if they are more double bond, that means they are more liquid in nature. So the liquid in nature, they have a lower melting point. Okay. So the one that is no double bond has a very high melting point. So you have to heat this formic acid, okay, as high as 72, baru dia start to melt. Okay. So because of the presence of double bond, unsaturated fatty acid are more reactive chemically than saturated fatty acid. Kan dalam kimia kan, we're talking about how energy kan, molecule have their energy. Normally dia akan lebih stable bila dia tak reaktif. Okay, so bila unsaturated fatty acid ni dia tend to be more reactive lah, because dia double bond, it is not as stable in terms of because it is always reactive. Kalau macam ada oxygen, dia akan react. Because of the double bond. So once dia dah jadi saturated, that is already saturated, dia dah tak boleh, they cannot, the structure, they cannot react with anything else anymore. So that means they already saturated lah, dia dah settle down. Okay, so because of the presence of this double bond, this unsaturated fatty acid, that's why they are more reactive than saturated. Okay, so this reactivity increase as the number of double bond increase. Of course, as we have 1 double bond versus 3 double bond, of course yang 3 itu lagi reactive, because dia ada 3 tempat untuk dia react with oxygen, for example. Okay. Although double bonds are normally occur in non-conjugated position, they can occur in conjugated position, alternating with single bond as illustrated below. Okay. Ini maksud dia, kalau conjugated tu meaning that dia berselang. Berselang meaning that lepas double bond ada single bond. Lepas double bond ada single bond. Okay. So that means you have 2, 1, 2, 1, 2. Macam tu. Okay. That is called alternating with single bond. That is what we call conjugated. Okay. Conjugated fatty acid. Okay. Conjugated tu bukan maksud dia conjugate tu dia macam apa, something that conjugate dengan dia. Okay, but it means that it is alternate. Double bond is alternate with single bond. Okay. Because most of the fatty acid that we found kan, dia punya double bond location, normally tadi ada 3, 6, 9, 12, 15 kan. So lepas 3, 4, lepas tu 5 kan. So normally dia akan less than that lah, dia bukan conjugated macam ni kan. Mana tadi? Sini kan. So dia ada 3, 6 and 9. So 3, 4, 5. Kalau conjugated dia ada dekat sini. Macam tu kan. Okay, that means dia alternate. Mana tadi? Sebab tu dia cakap kat sini, although double bond normally occur in non-conjugated position. Selalu macam ni lah. Okay, 3, 4, 5, 6. Okay, lepas 3, carbon number 6. Dia tak macam ni. Okay, but they also can occur in this type of position. Okay. So you have to know the difference between conjugated and non-conjugated. Okay, and then we go to the isomer. Okay, isomer of this one is saturated. Nanti betulkan. Okay, isomer is a compound that have the same molecular formula and molecular weight, tapi dia punya structure is different. Okay, different. Two types of isomer among fatty acid. One is geometry, one is positional. Okay. Kalau geometry, satu cis, satu trans. Cis tadi macam mana kan? Kita dah tengok. Cis tu, that means they have the same position yang location dia tu. Okay. Cis or trans ni geometric isomer depending on configuration of the hydrogen atom attached to the carbon joined by the double bond. Normally dia memang dekat double bond lah. So cis isomer are those naturally occurring. Trans isomer occur due to partial hydrogenation of OPA. This one that I mentioned, dia akan tukar daripada cis ni kepada trans. Maksudnya daripada yang dua sama, the H or the R group is the same, and then they change it to one upper, one lower, or one satu depan, satu belakang lah if you see in 3D. Okay, because of the partial hydrogenation. Trans also occur in ruminant. Ruminant ni mostly animals lah, animals. Okay. Transconfiguration melts at higher temperature. That's the reason why companies, industry, they tukar cis jadi trans. Because if your fat, your product melts at lower temperature, nanti dia tak stable lah your shelf life kan. Your shelf life is not stable. And also cis are normally liquid state at room temperature. So if, like I said, if you want to make the spread, but using olive oil to make the spread, macam mana nak jadikan oil to partial solid kan? Okay, partial solid, that means dia bukan actual solid tapi dia more easy to be spread. Okay, so dia guna hydrogenation procedure. So change to from cis to trans, or letak hydrogen, dia tambah hydrogen. Okay. So elydic and oleic acid packing, melting or solidification, dia akan effect lah the packing, the melting and solidification. Okay. And then we have another isomerism, which is positional. Okay, this positional, the location of double bond differs among the isomer. Okay. So this petroselenic acid, which is present in some animal and vegetable fats, dia adalah 6-octadecanoic acid. That means the location double bond tu dekat 6, tapi dia 6. 6, that means both of the H group or R group is the same position. Okay. And they are positional isomer of oleic acid, 6,9-octadecanoic acid. So that means although they are different in terms of the location of the double bond, tapi dia punya isomer are the same, 6 and 6,9. Okay. The racemic acid, which is a minor acid in tallow and butterfat, is trans 11-octadecanoic acid, and both a positional and geometric isomer of oleic acid. Nanti kita tengok apa yang oleic acid and also the position and geometric isomer of the racemic acid. Dia sama macam ni lah. Okay. Semua dia cis and cis or trans and trans. Okay, dia sama macam tu. Okay, so cis-9-octadecanoic acid. So dekat sini cis-9 and then trans 11-octadecanoic acid. Dia akan jadi trans lah. So dengan cis-9-octadecanoic acid, which is another oleic acid. This one yang petroselenic acid ni is present. Is cis-6-octadecanoic acid and positional isomer of oleic acid. So positional isomer of cis-9, dia kata yang ni, position isomer dengan yang ni, sama dengan yang ni. Okay, cis-9-octadecanoic acid sama dengan kita panggil isomer secara positional. Okay, petroselenic acid, cis-6-octadecanoic acid. Okay. Okay, then we go to the physical properties of PAG depending primarily on the structure, interaction, and organization of the triacid glycerol. Okay, so the attraction, the strength of the attraction or attractive attraction between these two molecules and effectiveness of the packing within a condensed phase. Maksudnya macam mana dia packing within this phase of the solid or liquid is largely determine, dia akan determine dia punya thermal behavior. Thermal behavior ni nanti tengok dia nak melting kat mana, solid fat content dia macam mana. Okay, Normally kalau thermal behavior kita ukur guna apa? DSC. DSC is scanning calorimetry. Okay. DSC density scanning calorimetry. So thermal behavior. Nanti kita akan tengok macam mana how this fat will behave accordingly lah. Okay. They also determine the density of the different fats and also the rheological properties of the fats. Okay. So physical properties of triacylglycerols. Okay. Most liquid triacylglycerol are Newtonian liquids where viscosity is about 30 and 60 MPa, okay, millipascal per second at room temperature. Okay, so these are the rheological properties. The viscosity of liquid oil tends to decrease steeply, okay, with increasing temperature. So this one we call it in terms of rheological properties in terms of viscosity lah. Okay, can be described by a log relationship. The log relationship kalau satu naik, satu lagi akan naik lah. Okay. Okay, log relationship. So solid fat, they consist of mixture of fat crystal dispersed in a liquid oil matrix. So when we talk about fat, we also have to know about what type of crystal. Fat ni dia ada crystal structure. So if you take a fat and you put at a slide, okay, microscope slide, and then you see under microscope, actually dia nampak crystal, okay, macam crystal structure, okay. So solid fat ni normally it exhibit a type of rheological behavior is known as plasticity. Plasticity, plastic material behaves like a solid, okay, below a critical applied stress known as PO or yield stress, but behave like a liquid above this stress. So dia akan ada satu ni, I don't know if you can see this picture. It is quite small here. So this is the PO. Okay. So the higher, okay. So kalau bawah, lower than this PO, okay, P0 or we call it PO, it will behave like a liquid. But if it's higher than this PO, it will behave like a solid. Okay, so this is called plasticity of the solid fat lah. So important implication of the products, okay, because kalau macam manufacturers they want to do a product, they normally study this the rheological properties of the products. Okay, nanti whether which type of shear rate, I think you will learn this in one of your physical. I'm not sure if your course, do you have a physical characteristics of food? Do you study that? The physical analysis of physical characteristic of food? Ada tak belajar dalam you punya course? Because we don't cover this in our chemistry. Actually, we cover this in physical properties of food. Kalau in food tech student lah, I think you learn this also, right? For your physical characteristics of food. Okay. Okay, and then that one is rheological. Rheological is talking about the viscosity lah. Normally viscosity, so bila ada satu solid and liquid, then the viscosity will be different. Okay. Density is a liquid of the mass. We're talking about mass over volume lah. Okay, ketumpatan, mass over volume. So it is important when we want to design food processing operation. Okay, this one maybe relates to you kan. Even the rheological pun very related to your program, right? Okay, density. So bila kita nak design satu food process operation, so you have to know how much. Macam kita nak design satu bulk tank, that you have the volume, right? And then when you put the oil versus when you put water, of course the density is different. So they will act differently. So it determines the amount of material that can be stored in the tank or flow through a pipe and given volume. This is the one that is very important for you to understand as an engineer, right? You have to take all this into account when you design a food processing operation. Okay, operations when you design an instrument for the food manufacturing. Okay, a certain food application because it influences the overall properties of the system. For example, creaming rate of all droplets in oil in water. This one very ni lah. So if you have a fat kan, kita ada ni, kita panggil macam yogurt, you have mayonnaise, itu kita panggil sistem apa tu? Emulsion. Okay, emulsion is a mixture of oil and water in oil. So you have to see either your emulsion is oil in water ke water in oil. Itu satu. Okay. So this will also affect all the properties of the food system. Okay. So this statement actually explaining, so this food application, okay, the creaming rate, bila kita nak buat oil in water system in an emulsion, the creaming rate is affected by the density of the PAG. Okay. Alright, and then of course thermal properties. Tadi kita mention about thermal properties. Thermal properties ni is important bila kita nak design macam what temperature to use, how it will behave at certain temperature. So it will involve the conductivity, it will involve the melting point, it will involve the enthalpy lah. And this is more of a physical properties. Kan? Satu lagi specific heat capacity kan. You learn this a lot in engineering, right? Specific heat capacity, thermal conductivity. I remember when I did this during unit operations, one of my lecturers are from engineering, so they taught us all this heat capacity. You have to design and calculate how much. Then I think you have that kind of courses in the program. Okay, so dia akan it will affect the CP, the specific heat capacity, the thermal conductivity on how much that the fat will be a conductor or using that specific thermal temperature, the melting point, of course, and then the enthalpy of fusion. Okay, knowledge of the temperature at which liquid starts to break down, it is due to the thermal degradation. It's quite important. For example, frying or grilling. Okay, thermal stability of liquid can be characterized by their smoke point, flash point, and also fire point. Okay, then we go to the ni punya part 1 sampai mana I'm using a different slide actually. Sini 66 kan? Yeah, I still have, let me see. Tak apa, dah habiskan sampai 66 sekejap Sekejap break sekejap 5 minit. Minum air kejap. Okay, I continue a little bit more. Okay, this is the composition of fats and oil. Composition meaning that what type of fatty acids that you will find in certain types of oil or fats lah. Okay, like cocoa butter, coconut oil, they are high in saturated fatty acids. Okay, and for coconut and palm oil, normally it has high medium chain fatty acids. It's either from 8 carbon to 14 carbon, with predominantly at 12 carbon, with no double bond. No double bond, meaning that it is a saturated fatty acid. Okay. Most vegetable oil, especially oil seed, vegetable oil ni normally dia punya oil normally it stays the source of the oil, it is in the seeds. Highly saturated and highly unsaturated and primarily fatty acid is carbon 18 or carbon 18. It has 18, 18.1, 18.2 or 18.3. Okay. So oil with high in oleic acid, which is canola and also olive. Oil that is high in linoleic acid is soybean or corn. And then oil with high linolenic acid normally is from linseed. Nanti kita tengok composition, each of the composition of the fat. It is not just that one fatty acid, it can be a mixture of fatty acid, because we're talking about triacylglycerides or triglycerides. Normally they consist of 3 fatty acids. Okay. So glycerides or acylglycerols, okay, over 99% of fatty acids are esterified to glycerol, or we call it acylglycerols. So these decrease the cytotoxicity and modify the surface activity. So A is actually the triacylglycerol. This one that I mentioned, the one that has kita panggil tri ni, meaning that it has 3 fatty acids. So triacylglycerol, it is the same as triglyceride. Whether we use TAG or we use TG, okay, triglyceride or triacylglycerol. So these there are the 3 fatty acid. Okay, 3 types of fatty acid that is actually become the triacylglycerol. Okay. So A is the triacylglycerol, B is the 1,2-diacylglycerol, sebab dia satu lagi ni diacylglycerol, one is the free OH group. Okay, free OH group. So which confer the polarity. Okay. And then this one is also diacylglycerol, monoacylglycerol. Okay, so kalau ada yang macam ni A, B, C, D, okay. C is this 1,3-diacylglycerol. D is the monoacylglycerol. So that means if you have a glycerol or glycerides, the acylglycerol that has not all has a full fatty acid of triacylglycerol, there are the OH. So this is one OH, this is one OH, this is two OH. So these 3 OH can be thereby contribute to the polarity of the acylglycerol, and this can be a good emulsifier. Apa maksud emulsifier? When do you use emulsifier? What is the function of emulsifier? Anybody know? Okay. So emulsifier like soy lecithin, soy lecithin can be emulsifier. Fatty acid, or we call it acylglycerol, can also be emulsifier if you have this OH group to give the solubility of water. So emulsifier ni dia adalah satu molecule ataupun satu compound or one sebahagian lah or compound that you can use it to mix the oil and also the water. So hydrophobic and hydrophilic compounds, dia akan jadi, dia tak separate lah. For example, macam yogurt kan, or we call it stabilizer. Sometimes they call it stabilizer, sometimes they call it emulsifier. So dia tak separatekan those two together. So macam kalau kita makan apa tu? Mayonnaise kan? Mayonnaise is a good example of using emulsifier kan. So if you just put the mayonnaise in the fridge or you put on the table, so it will not separate kan? Okay. So you can use this kind of fatty acids or acid glycerol as your as part of emulsifier because of the other OH group. So this is called partial glycerides or short chain are strongly polar than long chain. Okay. Mono and acid glycerol by very minor amount. Normally kita most of the fats that exist, they are more of a triacyl glycerol or bigger fatty acid. Okay, so a tracer or not full completed biological synthesis, for example, unripe food or seeds, sign of hydrolysis. So bila enzymatic hydrolysis, bila fats to starts to deteriorate, so dia akan ada sign or enzymatic through the enzymatic reaction lah. You can find those mono and diglycerols ni. Okay. Liquid and solid depends on fatty acid composition. Can be commercially prepared guna esterification. Okay. Affinity of both water and non-polar substance. So they can be emulsifier because it likes both water and also non-polar substance. It also has a higher vapor pressure than PAG. Okay, in the distillation process, kita nak distillate, we want to have the compound to be vapor, right? So kalau dia tengok how much of the pressure that we need to use, kalau dia needs a higher vapor pressure in the distillation process. So this mono and di has a higher vapor pressure lah as compared to PG. Okay. So any monoacyl glycerol is either a one monoacyl or two monoacyl glycerol. Kalau dia diacyl glycerol, it can have many other combination of fatty acid. Either they attach at C1, okay, or C2 position, or the C1 and C3 position. Kalau dia diacyl glycerol, okay, diacyl glycerol ni dua acyl glycerol lah, dua fatty acid. Kan? Kalau mono acid glycerol dia satu fatty acid. So that's why dia kata it can be C1, C2 or C1, C3. Okay, for the diacyl glycerol. It's just the positioning of the fatty acid kat mana. And then first and all, composed of mix, this one the very common one lah. Okay, very common one. Kita ada FA1, fatty acid number 1, fatty acid number 2, fatty acid number 3. Apa yang membezakan, what differentiate between these fatty acids are the R group ni. R group ni is how the chain tu lah, either C18, whether it is C16, whether itu kita panggil dia each of the fatty acid. Kan? Tadi we learn about oleic acid, stearic acid, palmitic acid, right? So here, depending on which type of acid that sits here, so dia yang jadi, so this triacyl glyceride ni, or triglyceride, what type of fatty acid will determine dia punya yang tadi tu kan, dia punya all those physical properties and also chemical properties. Okay, so fatty acid ni kalau dia guna the same fatty acid, so we call it simple glyceride or simple triglyceride lah, simple TG, because they use the same fatty acid for number 1, number 2 and number 3. So tiga-tiga, so all these three are from the similar fatty acid. But for the mixed triglyceride, okay, we can use it exists in macam R1, R2, R3. Okay, so you can either have different like C18, C16, C14. So dia different triglycerides. So this is called mixed triglyceride. This one is another example of how you want to change the the liquid to become solid. Macam tadi I mentioned one way is use hydrogenation kan. This is another method where you can exchange the fatty acid to change the oil and become solid and make it more spreadable. Ini satu cara lagi lah, kita panggil interacerification. Kita tukar dia punya fatty acid. Okay. Stereospecific numbering, the SN number, this is the numbering lah, kita panggil SN1, SN2 and SN3. So depending on where the location of the fatty acid tu. Okay, SN1 what fatty acid, SN2 what fatty acid, and SN3 which fatty acid. Okay. Plant triacid glycerol, preferential placement of unsaturated fatty acid dekat SN number 2 yang tengah ni. Okay. Right, saturated acid exclusive at 1,3 position and individual saturated and unsaturated fatty acid equally distributed at SN1 and SN3. Okay. For animal triacid glycerol normally is saturated as SN2. For example, C16 0 dia esterified as SN1. C14 0 dia dekat SN2. Okay, kalau kita tengok ni kan, macam tadi, okay, this one, for example, so SN1 dia tadi, dia cakap for animal lah, saturated fatty acid, okay, 16O, both are saturated also lah, 16O and C14O is at, one is an SN1 and SN2, satu dekat SN1, satu dekat SN2. This is mostly for animal hygiene. Short chain fatty acid selectively at SN number 3. Okay, this is a positioning of the SN1 to 3 depending on what type of fatty acid that you are looking at. Okay. Minor components ni kita dah mention tadi kan. Minor components of the lipids other than the major, these can be the minor components. Okay. Fatty acid, wax, pigments, glycosides, vitamins, okay. Phosphatide and phospholipid, this one, the one that I mentioned, the one that has ester of glycerol with the phosphate group. That's why dia ada phosphor kat sini kan. Phosphatide or phospholipid or phosphoglycerol. So ester of glycerol with phosphate group consists of alcohol, usually glycerol or fatty alcohol, okay, fatty acids, orthophosphoric acid, nitrogen containing compound. Okay, ini adalah dia punya components lah. Okay. Include vegetables, normally the percentage is about 0.1 to 3%. Okay. So for oil insoluble co-extracted as micelle with triacid glycerol during refining. Refining ni macam dia nak proses to extract the oil. Okay. So dia akan co-extract as micelle, micelle of the triacid glycerol. So this phosphorus content can be used as a quality of fats and oil. Okay. Amphipathic macam tadi tu, amphipathic molecule dia ada component that has hydrophobic and also hydrophilic component, so it can be a good emulsifier. Okay, I don't know if you can see this one. Okay, ni macam tadi lah, dia nak tunjuk where is the hydrophilic head. Okay, nanti dalam membrane. Okay, this is a good picture of a membrane. So in the membrane layer tu, dia ada phospholipid bilayer. We call it phospholipid bilayer because it has the head and also the tail. So the head ni dia consists of apa? Nitrogen dengan phosphorus. Nitrogen and phosphorus. So these are the structure lah, the structure. So this is the choline, the phosphate group, the glycerol group. Okay, and then the hydrophobic tail ni yang ada fatty acid tu kat sini, dia punya tail ni. Okay, so that's why kalau kat dalam cell, membrane cell, okay, the membrane, the inner part tu is the hydrophobic part because this hydrophobic part dia mostly dalam cell kan, kita punya membrane, the environment are mostly aqueous kan. So bila aqueous, this hydrophobic part, the tail ni, dia tak suka expose to the dia nak duduk dekat yang conserved region so that dia tak expose, they don't expose to the aqueous punya environment in the body, in the body or in the cell lah. So normally dia akan jadi macam ni lah. So despite where you have the hydrophilic part ni, dia akan ada satu phosphorus, kita panggil phospholipid bilayer. Okay. Sekejap. Okay, it is classified into 5 main groups based on the nature of substitute on the glycerol. This is the dia punya structure, dia punya structure. So if we X is an H, this is the name. So you just substitute the X ni kat sini, okay. So it become the different name, okay. Phosphatidylcholine, phosphatidylethylene, okay. You just gantilah the X group tu. So different charges as a function of pH, solubility and removal method. Okay. Ini just showing you the structure. Okay. Okay. Free fatty acids are non-esterified fatty acids. Okay, this is FFA. Okay. Some unrefined oil may contain as much as several % of free fatty acid. Okay, non-esterified. Kita tak buat any esterification punya procedures. Okay. The level of free fatty acid are reduced in the refining process only a few hundred of 1%. So free fatty acid can also be used as fat and oil quality. Kita boleh check juga dia punya free fatty acid value lah, free fatty acid value. Okay. And then sterols ni banyak dalam phytosterols. Phytosterols ni in plant lah. Kalau kolesterol in animals. Okay. Basic steroid structure, this is steroid structure. It consists of this aromatic group. Okay. Consists of 4 ring system with 17 carbon atoms. So these are sterols. Mostly you hear about plant sterols kan banyak diguna dalam formulation, like milk formulation. They use a lot of plant sterols in order to reduce the HDL to reduce the LDL. Okay, low density lipoprotein, okay, the cholesterol lah. Okay. It is found in both animal and vegetable oil, okay, cholesterol and phytocholesterol. The fat solubility, the other range lah depend on 0.05% to 0.6%. Okay. This one is the substitution at the skeleton by one OH and one or more metal and side chain. This one is tak apalah. This one is just to show. Nanti masa part 2 you can see more about the inter-esterification punya procedures lah. Okay. This one I will just skip the explanation for today. This one also tak apalah. This one is just to mention how the structure is different. Okay, if you change this R group at certain position. Okay, this one is talking about sterols lah. Okay, and then tocopherol and tocotrienol ini adalah apa? It is the antioxidant lah, antioxidant yang we use it a lot in formulation. Tocopherol, tocotrienol ni vitamin vitamin A kan, vitamin A, vitamin E. Okay, tocopherol and tocotrienol depending on this structure, depending on the R group ni. Okay, R group ni will confer with you what type of compound that is attached dekat R group ni, R1 and R2. It will give you different alpha, beta, gamma and also apa ni delta kan, delta. Okay. So kalau R1 ni, okay, and R2 are both CH3, so dia kita panggil alpha tocopherol. Kalau R1 is a metal group, R2 is the H, kita panggil beta tocopherol. Okay. Same goes to this one. You look at you just look at these R groups in it. The guide is here. Okay, then you can see the names of the alpha, beta, gamma, and also delta lah. Okay. This one is sama lah macam tadi. Members of vitamin E. These are fat soluble antioxidant. Banyak kita guna ni dalam food also, food ingredients. Okay. As an antioxidant. Okay. And added after processing to improve oxidative stability in finished product. Okay. Pigment ni tak apalah, nanti masa pigment kita tengok. Pigment ni can be as part of lipid also. Okay, chlorophyll, carotenoids. Nanti masa topik pigments tu, I will go in detail. Glucoside ni ether of mostly monosaccharides. Okay, many oil-bearing seeds and fruit pulps contain glycosides. Ni dekat plants lah. Okay, esterification of glycoside via the OH group. Okay, can make the oil insoluble. Okay, can make the oil soluble. Okay, vitamins. Nanti masa topik vitamins kita go in detail lah. Okay, I think I stop at 66 kan untuk part 1. Okay, it's already 5 o'clock. Okay, for tomorrow I will continue the part 2. Please watch the part 2 videos that I will upload after tomorrow. Okay, so thank you for your attention today. Any question? Nanti I will post this